Is a violin plot a combination of density plot and box plot? Whether you need good help, a genius writer, a brainy tutor, or a data wizard, Intuito4U has them all. It's like having a research dream team on demand.
You ever get that feeling that your data is holding out on you? You run the numbers, you make your charts, but you just know there's a deeper story hiding in there that you're not quite seeing? Well, today, we're going to pull back that curtain. So let's start with something we all know, right? The good old box plot. For ages, this has been the absolute workhorse for anyone looking at data. It's just a fantastic, simple way to get a quick snapshot of how your data is spread out.
You know the drill. It gives us that clean 5-number summary. You get the median right there in the middle, the box shows you where the middle 50% of your data lives, and the whiskers give you the overall spread, sometimes even flagging those weird outliers. It's clean, it's efficient.
But here's the catch with simplicity. Sometimes it simplifies things a little too much. It summarizes so well that it can actually hide the most interesting parts of the story. So you have to ask, what is this simple little box not telling us?
Okay, check this out. This is exactly what I'm talking about. We have 3 completely different data sets here. One has 2 distinct peaks, we call that bimodal. One is totally flat or uniform, and the last one is that classic bell curve, a normal distribution. But look at their box plots. They're nearly identical. The box plot sees the same summary stats and totally misses the actual shape of the data. Wild, right?
So how do we get around this? How do we see what's really going on? Well, allow me to introduce the hero of our story today. Meet the violin plot. This thing is such a smart hybrid. It basically takes all the useful summary info from a box plot and smashes it together with something called a kernel density plot. Just think of a density plot as a smoothed out histogram. It really is the best of both worlds.
And you know, this chart didn't just appear out of nowhere. It's built on decades of smart ideas. The whole journey kind of started back in 1952 with something called a range bar. Then in the 70s, the absolute legend John Tukey made the box and whisker plot famous. And finally, in 1998, Jerry Hinson and Ray Nelson put all the pieces together and gave us the violin plot.
So, how does this thing actually work? Let's pop the hood and take a look at the anatomy of this data violin.
This side-by-side view really makes it all click. On the left, you've got your classic box plot. On the right, the violin plot. And you can see how the most important parts of the box plot are just tucked right inside the body of the violin.
Now, that curvy outer shape, that's the magic. That's the kernel density plot we talked about, and it's just mirrored to give it that cool, symmetrical violin look. The logic is super intuitive. Where the violin is fat, that's where your data points are all clustered together. Where it's skinny, your data is pretty sparse. Simple as that.
And then, nestled inside, you've got all your familiar friends from the box plot. That little white dot, that's your median. The thick bar is your interquartile range, the middle 50%. And that thin line acts just like the whiskers, showing you the rest of the spread. It's a summary and the full detail, all in one package.
All right, enough theory. Let's put this thing to the test and see how it actually reveals the truth that other charts can miss.
And there it is. Remember that puzzle from the beginning? Solved. Look at what the violin plots show for those same 3 data sets. It's not even a question anymore. You can immediately see the 2 separate humps in the bimodal data, the flat, boxy shape of the uniform data, and that gentle curve of the normal distribution. The whole story is right there.
Here's a fantastic way to think about it, and it really sticks with you. A box plot gives you the skeleton of your data, the basic bones. But a violin plot, that adds the flesh. It shows you what your data actually looks like.
Let's take a classic real-world example, the old faithful geyser. A box plot would just show a pretty wide range of eruption times. Okay, fine. But the violin plot, it instantly shows you that the data is bimodal. There are 2 very different groups of eruptions, a bunch of short ones and a bunch of long ones. That is a massive insight that the violin plot makes completely obvious.
Or, how about this chart of academic salaries? When you break it down by rank, the violin plots show these interesting bumps and bulges. See how you can spot little clusters of higher earners, especially for full professors? That's the kind of thing that tells you, hey, there are some interesting subgroups in here you should probably investigate. It's a perfect tool for exploration.
And this really gets to the core of why they're so great, because they show you the entire distribution. They are an incredible tool for comparing the actual shapes of your data across a bunch of different categories all in one go. Okay, so it sounds pretty amazing. But is it the perfect instrument for every single analysis? Well, like any tool in the toolbox, it's got its pros and its cons.
Which leads us to the big question, right? Should you just throw out your box plots and use a violin plot for everything from now on? The answer is it depends.
I mean, the strengths are pretty clear. You get the whole picture, not just a summary. They're amazing at spotting those multiple peaks. You just get a much richer understanding of your data. And let's be real, they just look cooler than a plain box plot.
But on the flip side, we got to be honest about the downsides. If your audience has never seen one, it can be a little confusing at first. Some people argue the mirrored shape is just redundant. You're showing the same info twice. And they aren't always quite as direct as a box plot at pointing to specific outliers.
You know, I saw a comment on the data science subreddit that I think just nails it. The person said, box plots are great for normal distributions. Violin plots I like for distributions that are weirder. And that's really it, right? It's about using the right tool for the job.
So let's just break it down. Reach for a box plot when you need a quick summary, when your main focus is on the median and finding outliers, or when you just need to keep it simple for your audience. But you should grab a violin plot when you need to see the detailed shape, when you think there might be multiple peaks, or when your whole goal is to compare the form of the data between different groups. In the end, that's what this is all about, finding and telling the stories hidden inside the numbers. So the next time you're looking at a dataset, just ask yourself, what story might be waiting just beneath the surface if only I had the right instrument to see it?
And subscribe now for amazing videos just like that. Thanks for watching.